look at pH, and it's a concept that you'll be familiar with from year 7 when you did the pH scale. However, most people don't really understand what is actually meant by pH, and we're also going to have a look at what is meant by a strong and a weak acid, because this is often confused with pH. It's a very different thing because they see corrosiveness as strength, and it's not the same thing in chemistry. So we're going to have a look at the difference between those two things. But to start off with, let's have a look at what is actually meant by pH. So mathematically, pH equals the minus log 10 of the concentration of hydrogen ions. So this is the formula you would use to calculate it. You don't need to remember this formula, you just need to remember how it works. So this is my concentration of hydrogen ions. Log 10, that means that when you change something by 10, it will change something else by 1. So it's a way of sort of simplifying big numbers. And then you've got the minus, which means that as this goes up, this goes down. Okay, that's all you really need to know. If I give you an example, if I have, let's say, 1 molar as a concentration of hydrogen ions, and I dilute it by 10, so it becomes 0.1 molar of hydrogen ions, what will happen to the pH is it will go up by 1. So I've decreased the concentration by 10, which has meant that it's got the pH has gone up by 1. Similarly, if I was to make this 10 molar, then the pH would go down by 1. If I divided this, if I diluted this by 100, so it became 0.01 molar, the pH would go up by 2. Then if I did it by 1,000, it would go up by 3. So it's a factor of 10 causes a change of 1, and it goes in the opposite direction. Now, this is different to strong and weak acids because the concentration of hydrogen ions is what causes something to be corrosive. Now, all acids contain hydrogen and what's called a conjugate base. Okay, now as I put that into a solution, what will happen is, in the case of hydrochloric acid, it will form the acid, the hydrogen, and the conjugate base, so what we'll call A. This would be a strong acid. All right? The reason this is a strong acid is because it has a definition, and the definition of a strong acid is it fully dissociates the proton, and the proton is the hydrogen ion. So if I've got hydrochloric acid, once it goes into the water, it becomes H plus and Cl minus. They have nothing to do with each other again. It's basically like a strong breakup, right? Those two ions will never see each other again. However, let's have a look at what a weak acid is. So it's going to be slightly different. In a weak acid, when I take my acid and my conjugate base, when I dissolve them in the water, some of the acid, some of the hydrogen will separate from the conjugate base. Okay, so some of it will separate, however, not all of it will. So some of it will stay together, and that would be what we call a weak acid, because it partially dissociates. So that's the key difference here. It partially dissociates. So it's like those two individuals have broken up, they still have something in common that they need to talk to each other about. Okay, so they haven't completely separated, still in each other's lives, and that's a weak acid. A couple of examples here. So something like ethanoic acid will do this because the hydrogen will bounce from the two oxygens within the acid. Another really good example of this is sulfuric acid, because sulfuric acid, which is H2SO4, will fully dissociate into H plus HSO4 minus. So that's a strong acid there. That will fully dissociate. However, this will then only partially dissociate. So once that separates, it will form H plus SO4 2 minus plus HSO4 1 minus. So it won't all separate. So sulfuric acid is an example of something that acts as a strong acid and a weak acid. However, that is almost A level in difficulty. So for GCSE, you don't actually have to worry about that. That's just more for interest.